Hello everybody. In this lesson we will learn about the nth term of an arithmetic progression. We already studied what arithmetic progression is, what is called common difference, what is the first term, and how we generate arithmetic progression. So over here now we will study how to find the nth term of an arithmetic progression. So welcome to the lesson. So what's an arithmetic progression? An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. And what is this fixed number called? This fixed number is called the common difference. And remember, the common difference can be positive, it can be negative, or it can be zero. So let us try to generate an arithmetic progression in its general form. So what is the first term? Let us take A to be the first term of the arithmetic progression. What will be the second term? If D is the common difference, what will be the second term? The second term is obtained by adding the common difference D to the first term. So our second term is going to be A plus D. What will be the third term? We will add D to the second term. So A plus D will become A plus 2D. What will be our fourth term? We will add D to the third term. So it will be A plus 2D plus D. It will become 3D. And so on. What will be our nth term? Our nth term, we will figure it out. Can you guess what will be our nth term? Let us see how we go about. Let's look at our terms once again. Our first term is A. Our second term is A plus D. Can I write this as A plus 2 minus 1 times D? Because I am still getting A plus D. Let's look at our third term. Can I write the third term as A plus 3 minus 1 times D? It is A plus 2D. Our fourth term, can I write it as A plus 4 minus 1 times D? Because it is A plus 3D. So now, can you guess what will be our nth term? It is going to be A plus what? N minus 1 times D. This is denoted by the nth term An. So how can we find the nth term? It is A plus n minus 1 times D. So the nth term An of the arithmetic progression with first term A and common difference D is given by An is equal to A plus n minus 1 times D. What does A stand for? It stands for the first term. What does D stand for? It stands for the common difference. What does n stand for? The number of terms. The term number that we are finding. So remember this formula. Based upon this formula, we will be working out quite a lot of example problems. Let's look at this problem. Find the 10th term of the arithmetic progression. 2, 7, 12, and so on. So what is the first term of this arithmetic progression? It is 2. What is the common difference D? It is 7 minus 2. That's going to give you 5. We are supposed to find the 10th term. So what is n equal to? 10. What is the formula to find the nth term of an arithmetic progression? We know the formula over here. So now can we apply the formula to find the 10th term of the arithmetic progression? A10 is equal to the first term, which is 2, plus n minus 1, 10 minus 1 times d, and d over here is 5. So just use the calculation now. A10 is equal to 2 plus 10 minus 1 is 9, 9 times 5, 45. So the 10th term of this arithmetic progression is 47. Pretty easy. Good. Okay, let's try this problem. Which term of the arithmetic progression 21, 18, 15 on and on and on is negative 81? Also, is any term 0? Give reason for your answer. Now in this arithmetic progression, what is our first term? It is a equal to 21. That's our first term. What will be our common difference? Our common difference is 18 minus 21, which is going to be negative 3. We are supposed to find n. What is our nth term? It is negative 81. So what are we supposed to find? We are supposed to find n. Do we know what is the formula to find the nth term of an arithmetic progression? Yes, a is equal to a plus n minus 1 times d. Now we just have to plug it in and find the answer. Let's do that. So it's going to be negative 81 equal to the first term 21 plus, we don't know what n is, so n minus 1 times d, which is negative 3. Now we simplify. Minus 81 equal to 21, open the bracket, n times negative 3 minus 3n. Then minus 1 times minus 3 plus 3. So the next step is going to be negative 81 equal to 21 plus 3, 24 minus 3n. Simplify further, move the 24 on the other side of the equal sign. It becomes minus 81 minus 24 equal to negative 3n. And how much is minus 81 minus 24? Minus 105 equal to minus 3n. Now can you figure out what is the value of n? N is going to be negative 105 over negative 3. So what is that equal to? 35. So the 35th term will be negative 81 in this arithmetic progression. So we have answered the first part of the question. The second part of the question is any term 0? Give reason for your answer. In other words, we have to find out what is the value of n for which an is 0. So apply the formula, the same formula, an equal to first term. What was the first term? So the first term is 21 plus n minus 1. We don't know n, minus 1 times the common difference. The common difference was negative 3. So we open the brackets, simplify and find the value of n. So 0 is equal to 21 minus 3n plus 3. So simplify this. This is going to be 24 minus 3n equal to 0. So 3n equal to 24. N is equal to 24 over 3, which is equal to 8. So the 8th term will be 0 in the arithmetic progression. So the 8th term is going to be 0 in the arithmetic progression. So we have answered the second part of the question also. Good going. Keep working, keep practicing. Let's try this. Determine the arithmetic progression whose third term is 5 and the seventh term is 9. So we know the third term, A3, the third term is 5. And we know the seventh term, A7, that is 9. But do we know what is the first term? We don't know. Do we know what is the common difference? We don't know. But we know the formula for the nth term of an arithmetic progression. That is, an is equal to a plus n minus 1 times d. We know this formula. So let's plug into the formula the variables what we know. For the third term, a3 is going to be 5 is equal to the first term we don't know plus n minus 1. N, the third term, n is 3 minus 1 times the common difference. So this now is going to be 5 is equal to a plus 2d. This becomes one linear equation. Let's come over here to a7. We know the formula, so the seventh term, a7, that's going to be 9 equal to the first term a plus 7 minus 1 times d. So 9 is equal to a plus 6d. So now we have another linear equation. Now these are the two linear equations, a plus 2d equal to 5 and a plus 6d equal to 9. Do you know how to solve a pair of linear equations? Of course you know. You have studied this in solving a pair of linear equations by substitution or by elimination. Remember that? So we will use the method of elimination to find the values of a and d. Let's see how we go about doing that. So we know the two linear equations. We will solve these linear equations by the method of elimination. So we will change the plus to the minuses in the second equation. So then we will get plus a minus a cancels. 2d minus 6d is minus 4d equal to 5 minus 9 is minus 4. And d is going to be negative 4 over negative 4, which is 1. So now we know d. We can take the value of d and plug it into the first equation and find a. So we will have a plus 2 times d, which is 1, equal to 5. So a is going to be equal to 5 minus 2, a is going to be equal to 3. So we know the first term, we know the common difference. Now we can easily generate the arithmetic progression. The first term is 3. The second term is obtained by adding the common difference to the first term. So that's going to be 3 plus 1, 4. The third term is 5. Fourth term, fifth term, sixth term is going to be 8, seventh term 9, and so on. So this is the arithmetic progression whose third term is 5 and whose seventh term is 9. So this is how you do this kind of a problem. Let's try this. Check whether 301 is a term of the list of numbers 5, 11, 17, 23, and so on. Now, if you observe, the question does not say that it is an arithmetic progression. So before we even proceed, we have to first identify whether this is an arithmetic progression or not. And how do we do that? Check for the common difference. 11 minus 5 is 6. 17 minus 11 is also 6. 23 minus 17 is also 6. So the common difference is the same throughout. So therefore, this is an arithmetic progression. So discovering that, we now can move easily. So what is the first term over here? 5. What is the common difference? We found out to be 6. And what is the formula to find the nth term of an arithmetic progression? An equal to a plus n minus 1 times d. Check whether 301 is a term. So we are finding out 301. We are finding n over here. So over here we know that an is 301. What we need to find out is to which term does this belong. So we know 301 is equal to a, which is 5, plus, we don't know the term number, so n minus 1 times the common difference, which is 6. So if you open the brackets, 301 is going to be equal to 5 plus 6n minus 6. So 301 equal to 6n minus 1. So moving the minus 1 on the other side of the equal sign, so 302. 302 equal to 6n. So n is going to be equal to, n is going to be equal to 302 over 6, which if you simplify, n is going to be 151 over 3, which is going to be some decimal value. But n has to be a positive integer because n is a term, the term number. So n cannot be a decimal, neither can n be a negative. So therefore 301 is not a term of this series. Good. This is the way you do this kind of a problem. So 301 is not a term. 301 is not a term. You can write down that over here. Let's try this. How many two-digit numbers are divisible by 3? So what are the two-digit numbers that are divisible by 3? We have 12, 15, 18, and so on till 99. So these are the two-digit numbers that are divisible by 3. But does this form an arithmetic progression? Let's check it out. 15 minus 12, 3. 18 minus 15, 3, and so on. So it does form an arithmetic progression. So now we know what is our first term. A is 12. What is the common difference? D is 3. We are supposed to find how many two-digit numbers are there. In other words, how many terms are there. What is the last term that is divisible by 3 in this series? 99. So we know that an is 99. So now what we have to do is take the values and plug it into the formula. And the formula is an is equal to a plus n minus 1 times d. So we can easily plug it into the formula now, all the variables that we know. That is 99 equal to a, which is 12, plus n we don't know, n minus 1 times 3. And if you open the bracket and you simplify, you get n to be 90 over 3, which is 30. So there are 30 two-digit numbers that are divisible by 3. Let's try this. Find the 11th term from the last term towards the first term of the arithmetic progression 10, 7, 4, and so on. So what is the first term over here? 10. What is the common difference? 7 minus 10, which is going to be minus 3. So this is the common difference. We have to find the 11th term from the last. So let's do one thing. Since we have to find the 11th term from the last, but we are used to solving problems from the first. So we will reverse the list. So the reversed list, the first term will become negative 62. And when we are going backwards, the common difference will become, instead of minus 3, it will be 3. We have to find the 11th term. That means we know n is equal to 11. We need to find A11. How much is it? Now this becomes easy. Put it in the formula. An is equal to A plus n minus 1 times d. So A11 equal to minus 62 plus 11 minus 1 times 3. And if you simplify, A11 is going to be negative 32. So the 11th term from the last is negative 32. Let's try this. A sum of rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. Do these interests form an arithmetic progression? If so, find the interest at the end of 30 years, making use of this fact. So first of all, what is the formula to find the simple interest? We know that it's principal times rate of interest times time over 100. We have studied this in our lower grades. So the interest at the end of the first year is going to be how much? 1000 times 8 times 1, because this is the first year, divided by 100. That's going to give you 80. What will be the interest at the end of the second year? It's going to be 160. And what will be the interest at the third year? It's going to be 240, and so on. So what are the series that we get? It's 80, 160, 240. So the series that we get are 80, 60, 140, and so on. So does this form an arithmetic progression? 160 minus 80 is 80. 240 minus 160 is again 80. So yes, so it does form an arithmetic progression whose common difference is 80. What is the first term? A is equal to 80 again. So we have to find the interest at the end of 30 years. In other words, we have to find A30. So we can apply that in the formula. A30 is equal to A plus 30 minus 1 times D. And A is 80, D is 80. So what do we get? We get 2400. So the interest at the end of 30 years is going to be 2400. This will be our answer. Great going. We have completed the lesson on finding the nth term of an arithmetic progression. You are really doing well. Keep going, keep practicing. Only practice improves our skills. So I appreciate your dedication in solving problems, and I expect you to solve more and more problems on this lesson. Thank you for watching. Please share and subscribe to the videos for upcoming videos.